Okay, the next thing we need to figure out is if I give you a sequence, if I give you one, what is the recursive formula for that sequence? Okay, so I'm going to go over the process for this. Now, step one is to figure out what is your t sub 1. Well, your t sub 1 is the first term. So you're going to look at this sequence and find the first term in it. It's right there. And it's 30. And so your t sub 1 is 30. That was really easy, right? That wasn't too bad. Okay, so we got our t sub 1. Now we got to figure out our change. Remember, this is our start right here. Now we got to find out what's the change from each term to the next. Well, how do we change from going to 30 to 33? And from 33 to 36, and from 36 to 39, and to 42. What's the pattern? What's the pattern? Well, if you look at that and you think about it for a little bit, you notice that each time we are adding 3 each time, right? Adding 3. So, because we're adding 3 each time, our change is remember, this is like our next. T sub n is like our next. Our next term is equal to our t sub n minus 1. This is our now term. And then we're adding 3 to it each time. So whatever our now term is, add 3 to it, and we should get our next term. So that's your recursive formula right there. T sub 1 is equal to 30, and t sub n is equal to t sub n minus 1 plus 3. And you can try that out, right? If we take this 30, plug it in here, we get 30 plus 3. That's equal to 33. Oh, that worked for that one. Let's just double check it on 2 of them. We'll take the 33, put it in here. 33 plus 3. Oh, that's equal to 36. That was our next one. So, seems to work. Great, great. Okay, same applies down here. Let's try it on this one. One more example. We got to find our first term, right? That's the first thing we do. We find out it's a 4, so we put it right there. And then we need to figure out what's going on. What's changing from one term to the next. From here to here, and from here to here, and from there to there, and from there to there. What's happening to it? Well, in this situation, it's being multiplied by 4 each time. See that? 4 times 4 is 16. 16 times 4 is 64. 64 times 4 is 256. And 256 times 4 is 10,024. And if you do it times 2, you're at 2048. Is that a game you guys are all playing right now? 2048? Yeah, that's how math is related to games, right there. So anyway, because we're multiplying by 4 every time, let's use that. We know t sub n, our next term, is equal to, remember, this is our next. Our next term is equal to our now term, t sub n minus 1. Our now term times 4. Our now term times 4 will get us our next. And we can even try it. Take 4, plug it in to our now term. 4 times 4, does that give us 16? You bet it does. So, that is how you can come up with a recursive formula given a sequence. These are 2 basic ways of doing it. This one on top is when you're adding. You can see the same idea for subtracting. This one here is when you're multiplying, maybe even dividing. Sometimes they're going to integrate it together. They're going to have you find a recursive formula that not only multiplies but also adds, or not only divides but also subtracts. So keep your eyes open for those types. Those will get a little trickier. Okay.